Hello everyone, so welcome to the third lecture of Organic Chemistry Fundamentals. And before we begin with our topic, that is a formal charge, let's just go through to the solution part of the previous homework problem, that is writing the Lewis structures for these molecules. So these are the answers, you can just note them down, and if you connect all the two electron pairs, you'll get the total number of bonds. So if you know the structure, then you can convert each bond into a pair of electrons and represent the Lewis dot structure. And in some of the books, you might have seen that this sulfur oxygen double bond, instead of making a double bond, they have given a coordinate bond just to make sure that the sulfur doesn't exceed the octet, because in order to justify the octet rule, some of the Lewis structures are drawn in such a way that instead of drawing a double bond, they have drawn a coordinate bond, because then the sulfur will not have exceeded octet. So both are fine. You can draw a double bond, you can draw a coordinate bond, doesn't matter. Because ultimately we will be proving that the octet rule theory didn't hold in all the cases. So I think this is done. You can just note down all the structures and practice more structures from your books or from internet. Now let's move on to the next topic, that is calculating formal charge. Now about formal charge, what is the purpose of using formal charge? Why do we need to define a formal charge? Let's take an example of carbon. It normally has 4 valence electrons, and we say that it is neutral. It doesn't have any positive or negative charge. Suppose it gains an additional electron. So now the total number of electrons available must be 5. So because it gained an extra electron which was not its own, that is why we must write that one negative charge. So one negative charge indicates one additional electron compared to its valence electrons. So there are formulas for calculating the formal charge, but what I suggest is you understand the basic and then you won't need to memorize those formulas. So any element, it will have a valence electron, certain number of valence electrons. So when it only has the available electrons equal to valence electrons, then the formal charge is 0. If the available electrons are more than valence electrons, for example we have n additional electrons, then it will have minus n formal charge. If we have lesser electrons than its valence, then it must have lost those electrons. So if the total number of electrons are valence electrons minus n, then it will have a formal charge of plus n. Okay, I'll explain how to use this theory. For example, in this case, now this is the structure CH3NO2. Here what we need to do is, each bond, in all these bonds, one electron is from carbon. So how many electrons are available right now? Don't count all the electrons of the bonds. From this carbon, only these 4, because these 4 are the ones that were shared by the carbon. So it has these 4 electrons. Its normal valence is 4, available electrons are 4, so its formal charge is 0. Now this nitrogen, it has 1, 2, 3, 4. Only 4 electrons. Normally nitrogen has 5 valence electrons, but right now it has access to only 4 of them. So 1 less, so it will have a formal charge of plus 1. Okay, don't say that yes, this is a coordinate bond, it has given. No, each bond will be just 1 electron from this atom. For this oxygen, it has 1, 2, 3, 4, 5, 6. That is equal to just its valence electron 6. So formal charge of 0. This oxygen, it has 2, 4, 6 and 1, 7. So 1 more than its valence electron. So it will have a formal charge of minus 1. So whenever we write a coordinate bond, whenever you will be writing a coordinate bond like A to B, Either you represent it like this arrow, or you will have to represent it like this. The one that gives both electrons gets +1 formal charge, and the one who gets the coordinate bond gets a -1 charge. Okay, so you can represent the coordinate bond either in this form, or if you don't indicate in the arrow form, then you'll have to write +1 -1. Okay, that's what we did in this CH3NO2 molecule. Next, in this case, for this oxygen 2, 4, 5, 6, that is 0. Now this oxygen 2, 3, 4, 5, that is +1. This oxygen 2, 4, 6, 1, 7, that is -1. So when you add all these formal charges, they must be equal to the charge on the species. Now since this molecule is neutral, so adding up all the formal charges will also give you 0. This case here, nitrogen has only 4 electrons, one less than its valence of 5 electrons, so it gets a formal charge of +1. Then it represents the molecule NH4 positive. The whole molecule has +1 charge, that is why the formal charge, because each hydrogen has only 1 electron, so each hydrogen has a formal charge of 0. So net charge on the molecule is +1. Next, in this case, so you take 2 minutes of break, you solve all these 6 structures. Don't assign formal charge to hydrogen, but to carbon, oxygen, nitrogen, assign the formal charges, and then we'll see the answer to this. Now in the first one, the carbon has only 4 electrons around it, then it has a formal charge of 0. Second carbon has only 3 electrons, that is 1 less than its valence, so +1 formal charge. So this structure must be written as CH3CH2 1 positive. In this case, the carbon has 1, 2, 3, 4, 0. This oxygen has 1, 2, 3, 4, 5, 6, again 0. This oxygen has 2, 4, 6, 7, 1 negative charge. So this is HCO2 negative. Then this here, carbon has all 4 electrons. Nitrogen also has only 4 electrons, so the nitrogen must be getting a formal charge of +1. This carbon here, the carbon has 3 bonds with hydrogen and 4th here, so 0 formal charge. This carbon 1, 2, 3, 4, 0. Nitrogen 3 electrons here, and there will be a lone pair. If they have not shown the lone pair, it's your duty to make sure that you mention, or you at least represent the proper Lewis structure. The nitrogen must be having total 5 electrons in the bonding, so it will have a formal charge of 0 because 2 will be a lone pair and 3 involved in bonding. This oxygen here, 2 electrons, 3, 4, 5, so +1 formal charge. The carbon here 1, 2, 3, 4, 0. Oxygen here 2, 4, 6, 7, -1. So this means this will be written as CH3O negative. That is called methoxide ion. And what is this? This is the H3O positive hydronium ion. So that is about the formal charges. Now in the next lecture, we will be discussing about calculating degree of unsaturation, its usage while you are solving problems of calculating total number of isomers. So this knowledge of degree of unsaturation will be very useful while drawing all the possible isomers for a particular molecular formula. So let's just give you an idea. Before you come to the next lecture, try to write down all the possible structures for the molecule C4H6Bron. Okay, write down as many structures you can for this molecular formula, and then I'll explain how you can use the degree of unsaturation to simplify the whole process. Okay, so see you in the next lecture, and in the meantime, if you like this video, please share it among your friends because your support only will keep us going. Hit the like button and subscribe. Thank you. Have a nice day.